Every single day we walk through a world that's built on invisible rules. We trust that the bridges we cross, the offices we work in, the homes we live in will just stand up. But that trust, it isn't built on hope. It's built on a code. And today, we're going to pull back the curtain and see what that code is all about. I mean, think about it. It's such a fundamental question, but we almost never stop to actually ask it. We see all the steel and concrete, the glass and stone, but what are those unseen forces, that order, that turns all those raw materials into a skyscraper that can touch the clouds, or a home that can survive a storm? The ancient Romans had a perfect term for this, brutum fulmen. It translates to an empty threat or a senseless thunderbolt. Without a system, without a clear set of rules that everyone agrees on, the promise of a strong building is just that. It's an empty threat. It's all talk. It's the difference between chaos and actual construction.
Okay, so what is this system? Well, in India, the absolute backbone of safe, durable construction is a document called IS 456. The best way to think of it is as the invisible rulebook, the very DNA that gets coded into every single modern concrete structure across the country.
So its official name is a bit of a mouthful. Indian Standard 456, Code of Practice for Plain and Reinforced Concrete. But this is the single most important document for civil engineers. It doesn't just tell them what to do, it tells them how to do it. From the tallest skyscraper right down to a simple foundation, this code is the guide for safety and quality. And here's something you've got to understand. This isn't some dusty old book sitting on a shelf. It's a living document. It was first published way back in 1953, and it's been constantly updated ever since. The version we use today is the fourth major revision from the year 2000, and it's built on decades of research, real-world experience, and, learning from past failures.
Okay, so to really get how this thing works, let's start with the absolute basics. You can think of the code as the ultimate cookbook for concrete. And just like any great recipe, it starts by being incredibly specific about every single ingredient.
And this is where it gets really fascinating. The code doesn't just say use cement. No, it specifies different grades, like 33, 43, or 53 grade ordinary Portland cement. It even gets into special types, like sulfate-resisting cement for really harsh environments. It details additives like fly ash, the exact types of stone to use, and even the steel bars for reinforcement. Every little component is precisely defined.
And these rules, they get super practical, really fast. For example, the code tells you exactly how big the pieces of gravel can be compared to the size of the concrete beam you're pouring. Now, why on earth would it be that specific? Well, it's to make sure that the concrete mix can flow perfectly around all the steel bars, leaving no gaps, no weak spots. These aren't just abstract ideas. They're hard, physical rules that prevent buildings from failing.
Okay, this might actually be my favorite detail in the whole code. It is so thorough that it even specifies the quality of the water. According to Class 5.4, the water you use has to be clean and free from anything that could harm the concrete or steel down the line. Things like too much salt, acid, even sugar. And, the code doesn't just vaguely say, oh, the water should be clean. No, it quantifies it. This table here, which is a simplified version from the code, sets the exact maximum limits for different stuff dissolved in the water. For instance, if you have too many chlorides, they could eat away at the steel reinforcement from the inside out. This is how the code stops these invisible chemical attacks that could bring down a building years later. So we've got the perfect ingredients, but how do you put them together to build something that lasts? I mean, a building has to do more than just be strong on day one. It has to survive in its environment for decades. And that's where the code's obsession with durability comes in. Right, so Section 8 of the code is all about this one crucial concept, durability. It's the code's promise that a building will stay safe and functional for its entire life. This means designing the concrete to be a shield, basically, protecting the steel inside from rust and fending off attacks from chemicals in the air, the soil, or the water. And the code is smart. It knows that not every building faces the same fight. A concrete column inside a nice climate-controlled office, that's what the code calls a mild environment. But what about a pier getting slammed by salty sea spray, or an industrial floor that's exposed to harsh chemicals? The code classifies those as severe or even extreme conditions. And of course, the recipe has to change depending on that environment. As you can see in this table, as the conditions get more aggressive, the rules get way stricter. You have to use a stronger grade of concrete, and, this is critical, you have to use less water in the mix. See, a lower water-to-cement ratio makes the concrete much denser and harder for chemicals to get into. It creates a much stronger shield.
Okay, so you can have the most perfect design on paper, but it means absolutely nothing if it's not built right on the construction site. The code doesn't just stop at the design phase. It follows the concrete all the way from the mixing truck to its final home in the building.
So, sections 10 and 13 of the code basically walk you through this entire journey, step by step. First, the ingredients are measured, or batched, with insane precision. Then they're mixed until everything is perfectly uniform. The concrete is then moved carefully so the heavy parts don't sink. After that, it's poured and compacted, often with vibrators to shake out any trapped air bubbles that create weak spots. And finally, you have the most crucial and honestly most overlooked step, curing. So what exactly is curing? It's just the process of controlling moisture and temperature after the concrete is poured. See, concrete doesn't just dry out. It goes through a chemical reaction called hydration, and that's what gives it strength. The code says that for normal cement, you have to keep the concrete moist for at least 7 days. Skipping this step, it's like taking a cake out of the oven way too early. It will never, ever reach its full strength. So we've seen how the code lays out the recipe, how it designs for durability, and how it demands quality work on site. But maybe the most important thing about IS 456 is that it's designed to change, because the science of building never stands still, and neither does the code. And you can really see this evolution in action when you look back at its history. The 1978 revision brought in a totally modern way of designing structures. The 2000 revision, like we talked about, put this huge new focus on durability. And new updates or amendments are always being added. Like in 2007, when they added rules for new stuff like self-compacting concrete, which is a wild type of concrete that can flow into really complex shapes all by itself. And I mean, this is literally how it's done. When a new technology or a better way of doing things is proven, an official amendment slip is issued. This is the code, right here, physically learning and improving over time. It's how it makes sure it never becomes obsolete. You know, the code's own foreword really says it all. Its entire purpose is to keep abreast with the rapid development in the field of concrete technology. This isn't just a set of rules carved in stone. It's a scientific standard that is designed to evolve right alongside our knowledge and our ambition to build better, safer, and stronger. And that really leaves us with one final thought, doesn't it? IS 456 is the rule book that built our modern world. But as we invent smarter materials, design taller buildings, and keep pushing the absolute limits of engineering,